Jai Hind everyone. So this presentation is based on ER model of database management system, that is KCS 501. So before describing ER model, first we will discuss what is ER model and what is the role of models in DBMS. Basically, there are different types of DBMS model, network model, hierarchical model, ER model. ER model play a special role in DBMS because it is the relationship between or among entities. If these entities are correlated to each other, then it is treated as the relational database management system. Or ER model gives the opportunity to have to give or to provide to pictorial representation of a relationship between or among different entities. A database can be treated as a group of tables which are interrelated to each other. It means a collection of tables, and the relationship between or among these entities represent in pictorial form is treated as a ER model. Entity, what is entity? Entity is an object that exists and distinguishable from other objects. Like for example, an entity is a tabular format. Entity consists of various attributes. The attributes may have some entries. Entity set is a set of entities where different entities are combined to each other. Like a database is a set of entities, or database is a set of tables, and these tables or entities are interrelated with each other. What is attribute? Attributes are the properties of the entity. An entity is a customer. Customer have the property like customer name, the social security, customer street, customer address, customer city, account number, balance, the transaction. These are the attributes. What is the domain? A set of permitted value for each attribute. Like for example, if we are permitting in customer name, that customer name can accept varchar or the string value. So it can accept the string only. While social security, if we allow, the social security can accept only the integer value of 10 digits only. So it accepts the integer value and the size is 10 digits. So this is a domain. The attribute type can be a simple, composite, single valued, multi-valued, and null attribute. We will discuss it later. So we are focusing on ER diagram, ER model. So there are different symbols to represent ER model, because ER diagram is a pictorial representation of a relationship among different entities. Okay. So this is a strong entity. If we are drawing a rectangular box, the rectangular box represents the entity, strong entity. And this is our weak entity. The difference between strong entity and weak entity is that the weak entity set or weak entity do not have any primary key, while strong entity consists of a primary key. And primary key is what? Primary key is a uniquely identifiable key from which we can identify all other attributes of that particular entity. These are the attribute. This is multi-valued attribute. What is multi-valued attribute? If we are deriving some more attribute from that attribute, like for example, if we are giving a name, the name can be divided into first name, middle name, and last name. So name can be a multi-valued attribute in which first name, middle name, last name are combining. This is associative entity. Derived attribute. What is derived attribute? Derived attribute is that if we are entering or the database accepting the date of birth, but we can calculate the age based on the date of birth. We can calculate the today's age. So how can we calculate the today's age? Just subtract the inputted date of birth with the current date. We can get it the correct age of that person. This is a relationship. Diamond box represents relationship, and this is a weak relationship where if in a weak relationship there is no strong entity set is there. So these are the symbol to represent the relationship between or among different entities. Like if we are using this diagram, this symbol, so it is the one-to-one relationship. We can easily track that these are the relationship. This show cardinality. Cardinality means the relationship between or among different entities. Like for example, one-to-one relationship, one-to-many relationship, many-to-one relationship, or many-to-many relationship. So this is the cardinality of ER diagram, that one entity is related to another entity is a one-to-one relationship. This is one-to-many, and this is one-to-one only. This is one, only and only one. And this is 0 to 1, 1 to many, and 0 to many. So there are different types of this arrow symbols to represent the cardinality of the ER diagram. The relationship set. A relationship is an association among several entities. Like for example, there are 3 or 4 entities are there in a database, and these entities are interrelated to each other. So relationship is an association between several entities. But if I am asking what is the relationship, what is the difference between relationship and association? Association is the relation between or among attributes, while a relation is the relationship is the relationship or association between or among different entities. Attribute can also be the property of a relationship set. For instance, the depositor in this diagram, a depositor, this is the relation and this is the entity. These two entities are interrelated to each other by using depositor. Like for example, if a customer deposits some amount to his account, so the deposit on certain date, the person can deposit the amount. So we can identify that this is the account number, this is the final balance after depositing the amount or withdrawing the amount, and these are the attributes of the, or these are the property of customer entity. Roles. Entity set of a relation need not to be distinct. Like for example, employee. The employee can the properties of employees, employee name, e-security number, telephone number. The underline show that this is the primary key. And this works for worker. Means what? He employee works for worker. It is a manager. Employee can be a manager. Employee can be a worker also. So relationship cannot, it is not distinct. This relation, this entity is related to itself only. The label manager and worker are called roles. They specify how employees and entity interact via the works for relationship. Roles are indicated in ER diagram by labeling the line that connect diamond to rectangle. And roles labels are optional and are used to clarify semantics of the relations. This is mapping cardinality. We have already discussed the different types of cardinalities there, that one to one, one to many to many, or many to one. And we can show these cardinality in the means of these lines. Okay. So this is one to one relationship. Like for example, a customer can borrow a loan and loan can be related to this customer. If only one loan can be taken by the loan, so one to one relationship. There is only one customer and one loan. A loan account is associated to one customer and this customer is associated to one loan. If we say that a customer can take multiple loan, house loan, education loan. So this can be one to many. This relationship can be can again be changed to one to many if there are multiple loan accounts are there in a customer. Okay. One to many, we have already discussed. A loan is associated with the most of the one customer by borrower. In many to one, a loan is associated with several. Like for example, if we are discussing that, let's take this. This is one to many or many to one. Means what? Ki there are multiple customers have taken a house loan. There are multiple loans taken by a customer. A loan can be taken to loan can be borrowed by multiple customer. A customer can take in multiple loans. So this is a one to one, one to many, or many to one. Many to many. There are many customers are there and taken multiple types of loan. Like for example, 3 customers are there. First customer taken house loan and education loan. Education loan taken by the customer 2 also. House loan can be taken by the customer 3 also. So there are many customer and many loans are there. So in this way, this diagram show many to many relationship. There are different types of keys are available in database, because if we are discussing about the strong entity set, so we must know what is the primary key and what is the strong entity. How can we say that this is a weak entity? So first we know the super key. A super key is a group of single or multiple keys which identify a row in a table and that is uniquely identifiable. Super key. Primary key is a column or group of columns, or we can say group of single or multiple columns or attributes in a table that uniquely identify each and every row in that particular entity. Candidate key is a set of attributes that uniquely identify tuples in a table. Candidate key is a super key. Candidate key is a super key with no repeated attributes. Like for example, in a super key, we can say that A is a super key, A, B is also the super key. Okay. So what is the candidate key? We can take the candidate key is A only. There is no repeated. You can take A, B, but in A, there is only single key, that is A. So A can be the prime candidate key. Alternate key is a column of group of column in a table that uniquely identify each row, identify every row in a table. Foreign key is a column that create a relationship between two tables, primary key and foreign key. Foreign key is in another table and treated as a foreign key because this data can be fetched from the primary key only. Compound key. It has two or more attributes that allow you to uniquely recognize a specific record. And it is possible that each may not be uniquely by itself within the database. Composite key, it is a combination of two or more columns, like compound, if we are saying that name can be further divided into first name, second name, first name, middle name, last name. If we are combining all three, then it is a composite key. Surrogate key, an artificial key which aims to uniquely identify each record is to be called as a surrogate key. This kind of key are unique because they are created when you do not have any natural primary key. So there is a question that how can we convert weak entity set into a strong entity? So by keeping a surrogate key, how can we define this as a surrogate key? Surrogate key can be a serial number also. If we insert a serial number column, and the serial number is obviously it is uniquely identifiable key. So this can be a surrogate key. So this is these are the some example of what we have discussed in super key, primary key, candidate key. So super key is a group of single or multiple keys which identify a row in a table. A super key may have additional attributes that are not needed for uniquely identification. So this is an example. In the given example, employee SSN and employee number name are the super key because on the basis of this employee SSN, we can identify the employee number or employee name. On the basis of employee number, we can identify the employee name. So these can be separate. This can be a super key. Primary key in DBMS, it is a column or group of columns in a table that uniquely identify each row or every row in a table. The primary key cannot be duplicate, meaning the same value cannot appear more than once in a table. A table cannot have more than one primary key. But yes, there are more than one primary key, but you can designate only one primary key. Okay. So rules for defining the primary key. Two rows cannot have the same primary key value. No duplicate value is allowed in primary key. It must be every row to have a primary key value. Means there is no row or no entry that is blank or null. The primary key field cannot be null itself. The primary key cannot be null. The value in the primary key column can never be modified or updated if any foreign key refers to that primary key. If we already called that this is the, so let's say suppose there is a roll number 106 and 106 is fetched into another table as a foreign key. So 106 cannot be changed until unless we can remove the foreign key 106. If we remove the 106 from the foreign key, then we can change it. Okay. So these are the constraints. So in the following example, code student ID is a primary key. This is student ID because we can say that roll number also the primary key. Roll number is also the primary key. that 11, 12, 13, these are also unique. So student ID or roll number, both are the primary key, but mention that only one primary key can exist in a table. So if we are keeping student ID as a primary key, we cannot designate roll number as a primary key. If we are keeping roll number as a primary key, we cannot designate student ID as a primary key. So take only one. The student ID or roll number can be the primary key. Okay. Obviously, the email ID also can be treated as the primary key. Email ID also be treated because email IDs are also unique. No duplicate email ID can be created. So email ID can also be considered as a primary key. But there are different relation that which key we can consider as a primary key for this table. So because email ID is not known to everyone, but roll number easily we can track that this can be a roll number 1, 2, 3, 4, 5, 6 and so on. So this can be a primary key. What is the alternate key? It is a column or group of columns in a table that is uniquely identify every row in a table. A table can have multiple choices for a primary key, but only one can be set as a primary key. All the keys which are not primary key are called as alternate key. So in this example, if we are keeping that roll number is a primary key, then student ID and email ID in SQL a set of attributes that uniquely identify tuple in the table. Candidate key is a super key with no repeated attribute, or we can say the minimal super key is called candidate key. The simple definition is minimal super key is called candidate key. What does minimal? There is no repeated column. Okay, the primary key should be selected from the candidate keys, and each table must have a single, must have at least a single candidate key. A table can have multiple candidate key, but at a time only one single primary key can be designated. Okay, and these are the few properties of candidate key: that it must contain unique values. Candidate key in SQL may have multiple attributes, must not contain any null values. It should contain minimum field to ensure uniqueness, and uniquely identify each row, each record in a table. Okay, these are the foreign keys. Let's take this is the primary, this is a table, and this is another table. Okay, so these two tables, department code and teacher ID, these are the primary key, and these are the foreign key. So these are treated as a foreign key. This is primary key. Because in this table, department code is the primary key. In this table, teacher ID is a primary key. When we correlate each other like in this, so these can be this. Alternatively, we can treat it as this is a primary key, but if there are two, we cannot take it these two as a primary key. So we can do in this way. This is a primary key and this is primary key. These are treated as a foreign key. Compound key. It has two or more attributes that allow you to uniquely recognize a specific record. It is possible that each column may not be unique by itself within the database. However, when combined with other column or combination of composite key become unique. And the purpose of compound key in the database is to uniquely identify each record in the table. So in this example, order number and product ID cannot be a primary key as it does not uniquely identify a record. Like for example, this is the order number B005, B004, B005. This is a duplicate key. So we can keep it as a primary key. The product ID, this is also duplicate. So this cannot be a product ID. But the combination of order number and product key can be uniquely identified, because if we take B005, then this is a JAP, B004, then this is DKT, B005, this is OMG, B004, then this is DKT. DKT is a duplicate, but along with this order number, we can keep it uniquely. So in this table, order number and product key, both are the compound key and keep as this can be the primary key, combinedly candidate primary key also. Composite key is a combination of two or more columns that uniquely identify rows in the table. The combination of column guarantee uniqueness, through individual uniqueness is not guaranteed. Hence, they are combinedly to uniquely identify the record in a table. And what is surrogate key? If we are keeping any additional column in a table that uniquely identify each record is called the surrogate key. So this is the artificial key, or we can keep it as additional column. Like for example, if we are keeping a serial number in this, then we can treat it as a surrogate key. Weak entity set. The weak entity set which do not have any primary key and can be treated as a weak entity set. The existence of a weak entity set depends on the existence of strong entity set. It must relate to the strong set via one-to-many relationship and the among all the entities of a weak entity set. And this is the example of weak entity set, like this payment number, payment number, payment date, payment amount. This is the payment number 1, 2, 3, 4, 5. So this is the weak entity, and this is related with the loan, where loan number is the primary key and this is the relationship. Okay. Specialization. So we have talked about the ER model. So ER model is basically depend on different types of keys, because keys are interrelated to each other. Like if we are creating a primary key, then it is related to foreign key. The primary key can be extracted from the super key itself. Candidate key itself extracted from the super key. So the importance of identification of keys is very important. Like only after identification of keys, we can able to correlate the entities. So that's why we have discussed various types of keys. Now, the one entity is related to another entity with the different cardinality, one to one, one to many, many to many, or many to one. So these are the some additional cases of ER diagram. Like if I am saying that what is extended ER model or extended ER diagram, everyone knows that extended means somehow the bigger one or the larger one, or some additional component will be added to existing ER model. Okay, so this is not the meaning of extended ER diagram or extended ER model. Extended ER model means if we are designing the ER diagram in a new way, like for example specialization or generalization. These are the extended ER diagrams. Like in specialization, if we are talking about an employee can be a part-time or full-time employee or temporary employee. So employee can be further divided into three categories. Okay, so this is a top-down approach where the employee can be divided into three different types of employee: permanent, temporary, or full-time. Yeah, full-time, part-time, or temporary. So these are the different types of, like for example, if we are talking about the account type, there is a saving account, there is a current account. Okay, so the top-down, it is a top-down process, and we designate subgrouping within an entity set that are distinctive from other entities in the set. These subgrouping become lower level entity set that have attribute or participating in a relationship that do not apply to a higher level entity set. And this is represented by a triangular shape. This triangular shape, this. If we are keeping this as an employee, so this can be part-time and this is full-time employee. So these are the entity. Entity can be broken into two, full-time and part-time. So this is specialization. Like for example, this is the diagram of specialization. This is the case of specialization where there is an account, where account number and balance. The account is a saving account or the checking account. Okay. A checking account can be a standard, gold, or senior account. So in this way, we can identify the entity can be further broken into sub entities. And keep in mind that the attributes of this account, the attribute of this can also be the attribute of this senior account also, with some additional. Like for example, if we are keeping this a senior account, obviously if a senior account is there, then its date of birth is mentioned, because it is the only way that we can find that this is a senior account. So senior account, date of birth, and this date of birth also be the attribute of this DOB. We have not mentioned here, just that you are not creating any confusion, that this particular entity has all the attributes which belongs to these further entities. Okay, so this is how we can divide a single entity into multiple entities. So this is a specialization example, and this is the case of extended ER model or extended ER diagrams. Now, second is generalization. In this, these three are the accounts. If we are keeping that these all are the checking account, a checking account and saving account can be treated as an account only. Like for example, if we are keeping that bottom up approach, like this is the example of specialization top down approach. This is treated as specialization. The reverse of specialization, this is treated as generalization. The reverse of specialization. Like, and the diagram, obviously, the diagram will be reversed. These are the different types of account, and these accounts can be combined into a checking account, and this checking account and saving account can be converted into a single account. So this is the generalization, a bottom-up design approach, where we can combine a number of entities that share the same features into a higher level. Specialization and generalization are the simpler inversion of each other. One is top-down, another is bottom-up approach. Okay. So these are the design constraints of generalization. The design constraints are that it can be condition defined or user defined, and can be disjoint or overlapping. So these are the some design constraints. This is aggregation. Aggregation is what? Loan customer may be advised by a loan officer. Like for example, if there are multiple entities and these entities are correlated with each other in this way. So we have to do in this way, like this loan entity is related to employee, is related to customer. This should be not to be done. This should be done in this way. Like loan account is related to customer and borrower is related to employee. So this particular diagram, a combined diagram where these three entities are interrelated to each other. Like for example, loan officer, this is related to loan and this is related to customer. Obviously, this particular loan officer is related to this borrower. So we can keep it as. So this is the aggregation example. In aggregation example, we have to keep that there is no duplicate relationship exist. Like in this case, the duplicate relationship is that the loan officer is related to loan. The loan officer is related to loan by customers also. So this is a cycle. So we are removing these. We are keeping that loan officer is related to borrower and this borrower relationship is related to customer as well as the loan. So this is the aggregation example. So these are the ER design decisions, that the use of attribute or entity set to be represented an object, whether the real world concept is best expressed by an entity set or a relationship set, the use of ternary relationship versus a pair of binary relationship, the use of strong and weak entity set, the use of generalization or aggregation. Generalization, specialization, aggregation. It is must. And this is the example of ER diagram of a banking system, that there are some entities: branch, customer, loan, payment, employee, account, and this is it means this is a specialization, and this is a weak entity. So weak relationship, and these are the strong because all have the primary key. This has a weak relationship payment number. Okay, so this is how we can draw the ER diagrams. Okay, so that's all for today. In the next lecture, we will discuss another important topic. Thank you for now.